Hi guys, welcome to Science in 5. In this video we're going to discuss displacement in one dimension. Now, when we discuss displacement in one dimension, we've got to appreciate this idea that if you move in one direction and then you consider the exact opposite direction, one of those directions has to be negative. Okay? So in the case of movement along the x, it's easier to make the east positive and then you make the west negative. Okay, so you'd say movement in the eastern direction is positive, movement in the western direction is negative. That will help a lot. Later on, as you go on with vectors and discussing adding vectors, you discover that you can actually make the east negative and you can make the west positive. Sounds a little bit complicated. That's why for introduction, maybe let's just stick to the east is positive and the west is negative. Okay. Now, let's suppose we've got an object that is moving from a certain position. We want to determine its displacement. How would we do that? Well, to determine displacement is easy. Displacement is simply the change in position. Okay? So if we've got an object that is located at -8 according to this reference system, okay? According to this reference system that we've got, this object's position is -8, or it's 8 meters west of the reference point, the reference point being the 0 point, okay? And this object moves from its initial location to a new location. So the initial location, we call it xi, and then the final location is xf, x initial, x final, okay? We can actually calculate the displacement of the object by saying displacement equals final position minus initial position. In this case, the final position is the -4 position. The initial position is the -8 position. This will give me a +4. Now, the +4 tells me that I have moved in the positive direction. So this positive here means I have gone in this direction, which is the same as the what? The east direction. Okay, so positive movements mean I have moved east. If the answer had been a negative, then the sign would have told me I've gone west. Okay, so the displacement is always drawn as a vector, a straight line from the initial point to the finishing point. Always draw a straight line from the starting point to the finishing point. The direction which you take will give you the direction of the displacement. In our case, the displacement here is 4 units, and we said it's in the positive direction. But we don't want to write our answer as 4 units positive. We would rather change the positive into east. So our displacement is 4 units east. What if an object moves in one dimension, but it changes its direction? Can we calculate the displacement in that case? Suppose we have an object located at the +8 position, and it moves all the way to the -8, but it doesn't stop there. You notice the object changed direction and moved to the -4. So in other words, there were 2 movements. One movement was in the western direction, the other movement was in the eastern direction. Okay, so there are 2 movements that the object made. Now, if we wanted to calculate the distance traveled by this object, we'll need to add the 2 movements. The first movement is the 16, the second movement is the 4 units. So the total distance traveled would be 16 added to the 4 units. This will give you what? A total of 20 units. So the total distance traveled is 20 units. Remember, distance, unlike displacement, distance is a scalar quantity. It just measures the length of the path traveled. How long is the path? Okay. Whereas displacement is a vector quantity. It's a straight line movement from start point to finishing point. In other words, the change in position. Okay. What was the initial position? The positive 8 position. What was the final position? The negative 4 position. So now I can calculate the displacement of this object. It's a straight line movement joining the start point and the finishing point. So the displacement in this case is -4 minus 8. This gives me -12. We've already explained what the negative or the positive on the final answer means. In this case, negative means we are pointing in the negative direction. We can convert that to 12 meters west. So my displacement is 12 meters west. Okay. But we can also look at this displacement of this object in another way. Displacement is a vector quantity. When an object moves like this, changing direction many times, we can consider each of the separate movements as displacements themselves. Okay? So for example, the first displacement we can look at is the -16. In other words, the object moved from 8 to -8. So it went in the negative direction. The displacement there was -16. Then the object changed direction and went into the positive direction. In the positive direction, the object moved 4 units. So x1 can be used to represent the displacement, the first displacement of the object, the -16, and let's use x2 to represent the displacement in the positive direction, the +4. So the total displacement would be the sum of the individual displacements, x1 plus x2. The displacement vector x1 plus the displacement vector x2 will give us the total displacement traveled by this object. So we get -16 plus 4. -16 plus 4 will give me -12. Again, at this stage, we are now aware of what a -12 means. A -12 means we have moved 12 in the negative direction or in the west direction. So I would leave my answer as 12 meters west. So the total displacement is still 12 meters west. So there's my x total. So you can add displacement, you can treat displacement like that, especially when the object moves in one dimension. One of the displacements can be positive, can be negative, if the object changes direction. So if the object changes direction in one dimension, then it means one of the displacements has to be negative, one of them has to be positive. The easiest reference system that you can use when you're introducing vectors to yourself or you're learning about vectors for the first time, just say east is positive and make west negative. Later on, when we start dealing with motion, you can discover that sometimes it's actually useful to make the west positive and the east negative. But that's it for now, guys. So displacement is the change in position, the final minus the initial. Once you get that, determine the direction and then write your answer as the magnitude and direction. So that's displacement in one dimension. I'll see you guys next time, probably when we discuss displacement in 2 dimensions. For now, ciao. Science made easy, Science in 5.